March 3, 1944. East Anglia, England.
Lieutenant William Overy tightened his grip on his pencil as he wrote to his sweetheart back in Virginia, his hand shaking slightly from fatigue rather than fear. Tomorrow we're doing something everyone said couldn't be done, flying all the way to Berlin and back in a single-seat fighter.
The senior officers kept insisting it was impossible.
Through the window of his quarters, he could see ground crews laboring beneath floodlights, fastening odd cylindrical shapes under the wings of his P-51 Mustang. They appeared to be made of cardboard, these new fuel tanks wrapped in brown paper like parcels from home. Some of the men were calling them paper bags.
The crew chief laughed when Overy questioned their dependability.
"They're made of laminated paper and plastic resin, Lieutenant.
Same stuff the Brits have been using.
They'll hold fuel long enough to get you there and back." The equations of aerial warfare were about to be rewritten not by superior armament or advanced metallurgy, but by compressed paper saturated with resin, manufactured in a converted newspaper plant by workers who normally printed the London Times. The crisis had reached a breaking point on October 14, 1943, Black Thursday. Colonel Hubert Zuckert stood before the operations board at Halesworth, watching mission reports arrive like casualty rolls from the Western Front.
60 B-17s lost. 600 men gone in a single day.
Of the 291 flying fortresses dispatched against Schweinfurt's ball-bearing factories, 60 were shot down by German fighters and flak.
Another 17 were damaged so severely they were scrapped. The losses totaled more than 26% of the attacking force. Without long-range escort, the daylight bombing campaign was hemorrhaging over Germany.
Among those returning to Thorpe Abbotts was Technical Sergeant Robert Morgan, a ball turret gunner with the 100th Bomb Group. His statement to intelligence officers was blunt.
"The Jerrys waited until our little friends turned back at Aachen.
Then they came at us in waves, head-on attacks, rockets from twin-engine jobs sitting outside our gun range. We were sitting ducks for 3 hours. The P-47 Thunderbolts, formidable as they were, could only reach 375 miles with standard drop tanks. German fighters simply waited beyond that invisible boundary in the sky, then ripped into the bomber formations with systematic precision." In a small office within the 8th Air Force Technical Section at Bovington, Colonel Cass Hoff examined something that looked more like a school project than military equipment. It was a fuel tank built from laminated craft paper infused with plastic resin, produced by Bowater Lloyd of London, the firm that usually supplied newsprint to Fleet Street.
Hoff had spent months refining this unlikely solution to the range problem, collaborating with British engineers already experimenting with non-metallic drop tanks alongside Colonel Bob Schaefer. The British effort was driven by necessity, metal shortages were acute, and every pound of aluminum was valuable. Hoff, however, recognized another benefit.
These paper tanks weighed roughly 50 pounds empty, compared to 150 for metal versions. The weight reduction translated directly into increased fuel load and extended range. Construction involved multiple layers of craft paper bonded with resorcinol formaldehyde adhesive, molded over wooden forms with internal wooden anti-slosh baffles, then sealed with fuel-resistant lacquer and aluminum paint, giving them their distinctive silver finish. The first combat trial came in February 1944, when P-47s of the 56th Fighter Group flew with British-made 108-gallon paper tanks. Major James Goodson led the mission, later reporting that the tanks performed flawlessly to Hanover and back, with no leaks or failures, extending range by 125 miles. But this was only the beginning. The pace of change accelerated with the arrival of the P-51B Mustang at Debden in late February 1944. Colonel Donald Blakesley's 4th Fighter Group, the 334th, 335th, and 336th Squadrons, received their first Mustangs on February 28. Pilots had less than 24 hours to convert from Thunderbolts. Captain Don Gentile, who would become one of the war's leading aces, logged just 45 minutes in the Mustang before his first combat sortie. Yet it was the pairing of the Mustang and paper drop tanks that transformed everything.
The Mustang could carry two 108-gallon paper tanks, now being produced in growing quantities at Bowater Lloyd's facilities in Sittingbourne and Kemsley.
With them, the P-51's combat radius expanded to 850 miles. Berlin, 580 miles from East Anglia, was suddenly reachable.
The morning briefing on March 4, 1944, at Debden crackled with tension. Intelligence Officer Major John McCulpin drew back the curtain on the mission map.
A red ribbon stretched from their base all the way to Berlin.
For the first time, single-engine fighters would escort bombers to the enemy capital and return.
The 1,100-mile round trip marked a historic turning point that fundamentally altered the strategic bombing campaign. Captain William O'Brien of the 357th Fighter Group recalled the moment decades later. "You could hear a pin drop. Then someone whistled, 'Berlin.'
We were going all the way in fighters. The crew chiefs had been filling the paper tanks since 0300 hours, carefully. The tanks would only retain fuel for about 5 hours before gasoline began degrading the resin, but 5 hours was sufficient. The engineering behind the paper tanks was deceptively advanced. They consisted of 3 primary components: nose cone, tail cone, and central body. The main section was formed from layers of impregnated paper wrapped around a cylinder, while the end caps were hand-laminated from pedal-shaped pieces known as gores. Each tank held 108 US gallons of 100-octane aviation fuel, sometimes listed as 110 gallons total with 108 usable. Measuring roughly 100 inches long, the tanks were pressure tested to 6 psi and performed reliably from sea level to 40,000 feet in temperatures ranging from -60 to +120 degrees Fahrenheit. Workers at Bowater-Lloyd, many of them women formerly employed in newspaper printing, along with production spread across additional facilities, including decentralized manufacture in British homes and workshops, produced the tanks in ever-increasing numbers. As 1944 progressed, skepticism persisted within parts of the American aviation establishment, even as combat operations confirmed the tank's effectiveness. Right-field technical experts declared that paper tanks were entirely impractical and incapable of fulfilling their intended role. By the time this judgment reached England, however, the 8th Air Force had already employed more than 15,000 paper tanks without a single failure attributable to their construction. Colonel Hoff's response was characteristically blunt. He pressed production forward, confident that combat results outweighed laboratory opinion. Doubts from right field became irrelevant in the face of operational success. The first escort mission to Berlin on March 4 saw P-51 Mustangs and P-47 Thunderbolts accompany more than 700 heavy bombers to the Nazi capital. Leading the Mustangs was Colonel Blakesley, whose pre-mission briefing was recorded by intelligence officer Captain John Slater. "These paper tanks will get you there and back. At the initial point, punch them off and engage enemy fighters. With these tanks, we own the sky all the way to Berlin." The mission was not without loss. The 4th Fighter Group lost Lieutenant Alan Bate, shot down by flak near Brandenburg. Yet the psychological impact on both sides was profound. Luftwaffe pilot Oberleutnant Heinz Nock of Jagerschwader 11 recorded in his diary his shock at seeing American fighters over Berlin, noting that intelligence had insisted this was impossible and that everything he had been told was wrong. For bomber crews, the sight was transformative. Ball turret gunner Sergeant Dale Rice of the 100th Bomb Group later described approaching the initial point and spotting P-51s at 30,000 feet, contrails streaming behind them. One waggled its wings as it passed overhead, and he could clearly see the drop tanks beneath the wings. The impact was immediate and dramatic. On March 6, when bombers returned to Berlin with Mustang escort, Luftwaffe interceptions decreased significantly. Major Walter Nohn, one of Germany's top aces with 258 victories, reported to Luftwaffe High Command that the Americans had solved the range problem and that their tactical advantage was gone. The production chain for paper drop tanks exemplified Allied industrial cooperation and innovation. Bowater-Lloyd, which had been producing 60% of British newsprint before the war, converted portions of their facilities at Sittingbourne in Kemsley to tank production. The company's experience with paper lamination and their access to raw materials made them ideal for this work. The craft paper came from recycled newspapers and packaging materials, while the resource null formaldehyde glue was produced at Imperial Chemical Industries plants using materials that didn't compete with other war priorities. The entire production process from raw material to finished tank took approximately 72 hours. Additional production came from distributed manufacturing across Britain, with workers in home workshops contributing to the war effort. The tanks were wrapped in heavy brown paper for shipping and could be transported efficiently with far more paper tanks fitting in transport aircraft than metal tanks. Master Sergeant Donald Manor of the 357 Fighter Group responsible for drop tank logistics at Lyon kept detailed records that survived the war. His team would begin work at 0200 hours on mission days, unwrapping tanks, checking seals, and mounting them on aircraft pylons. The mounting system was elegantly simple, with tanks attaching to standard bomb shackles with a quick-release mechanism, a pull of a lever in the cockpit would jettison both tanks simultaneously, essential for combat maneuvering. The fuel feed system used the aircraft's existing plumbing with check valves preventing fuel loss when the tanks were released. The critical Limitation was that the resourcenol blue would slowly dissolve from the fuel's solvent effects, causing leaks within
hours, making these strictly single-use items that had to be filled immediately before takeoff. By May 1944, the impact
of long-range fighter escort was measurable in stark numbers.
Before the introduction of effective long-range escort, the 8th Air Force experienced catastrophic losses.
October 1943 had seen monthly loss rates of approximately 7.6%.
with individual missions like Black Thursday reaching 20.6%. Once P-51s with drop tanks began regular escort missions, the overall campaign
loss rate dropped to between 1.5 and 2.2%.
This dramatic reduction saved thousands of aircrew lives and made the strategic bombing campaign sustainable.
Technical analysis by Republic Aviation.
Engineers revealed unexpected advantages of the paper tanks beyond weight savings.
They had better aerodynamics than metal tanks, creating less drag. They were also less likely to explode
when hit by enemy fire, as the paper and resin construction would tear rather than fragment. The tanks were partially biodegradable, breaking down within months when left in fields or forests,
unlike metal tanks that became permanent hazards to farming. Lieutenant Colonel John Meyer, who would
end the war with 24 aerial victories, flew the March 6 mission to Berlin.
His combat report, preserved in the National Archives, provides detailed pilot perspective on the paper tanks' performance at altitude.
He took off at 10:45 hours with two 108 gallons paper drop tanks, experienced perfect fuel transfer throughout the flight, released tanks at
1,347 hours near Wittenberg when bounced by FW-19S, and engaged immediately after release. The weight difference after dropping the tanks dramatically improved aircraft performance.
He shot down one FW-190, damaged another, and returned to base
with 45 gallons remaining.
Without those paper tanks, he noted, they would have turned back at Brunswick. The strategic impact extended beyond just bomber protection. With extended range, American fighters could conduct fighter sweeps deep into Germany, attacking airfields, rail yards, and targets of
opportunity.
Colonel Hub Zenka, commanding the 56th Fighter Group, conducted a tactical
analysis in May 1944 that concluded the extended range provided by British paper tanks had fundamentally altered the air war, allowing them to seize the initiative completely.
German response to the Allied range advantage was documented in captured records after the war.
A technical intelligence report from Mesmet AG dated May 15, 1944,
acknowledged that the enemy was using disposable fuel tanks of revolutionary construction with laminated paper and
phenolic resin impregnation.
They had attempted to duplicate this technology,
but lacked the industrial infrastructure for mass production. The German attempt to copy paper tank technology failed not
for lack of technical knowledge but due to systemic problems in their war economy.
They lacked paper production
capacity, with most German paper mills converted to producing military maps and documentation. The resin materials were prioritized for aircraft construction.
Most critically,
they lacked the distributed manufacturing model that made Allied production so resilient.
The Luftwaffe's senior leadership understood the implications immediately. In post-war interrogations, high-ranking
Luftwaffe officers acknowledged the strategic impact of long-range fighters.
While the specific quote often attributed to Hermann Göring about seeing Mustangs over Berlin cannot be verified,
in primary sources, documented testimony from the U.S. Strategic Bombing Survey
shows he stated that long-range Allied fighters delivered a major strategic blow to German planning and were one of the most decisive factors in the ultimate outcome.
He acknowledged that when fighters
appeared over Berlin, the results would be, in his words, tragic for Germany. General Diekfleger Adolf Galland similarly testified that American fighters ranging over all of Germany
with impunity had effectively broken the Luftwaffe's defensive strategy.
By June
1944, paper drop tanks had become standard equipment for fighter operations. Sergeant James Patterson, quartermaster at Duxford, maintained logistics records, showing that paper tanks required 1/10 the shipping space of metal tanks when transported from factory to
airfield. A single C-47 transport could carry hundreds of flattened paper tanks, compared to 40 metal tanks. This efficiency meant forward airfields in France after D-Day could be supplied by
air, maintaining operational tempo even when ground supply lines were stretched.
The environmental impact, though not a consideration at the time, was documented by French farmers after the war.
Metal tanks that littered fields killed cattle, damaged plows, and
required extensive cleanup lasting years. Paper tanks dissolved in rain over winter, leaving only metal fittings that could be sold for scrap. Captain Donald Bryan of the 352nd Fighter Group experienced one of the rare tank failures on July 18, 1944, the only documented case in his squadron. The port tank developed a leak at 25,000 foot over Hanover, losing about half the fuel before he could switch it off. He still made it home with fuel to spare from the starboard tank, demonstrating the redundancy built into the system. Technical improvements continued throughout 1944.
Second-generation paper tanks featured improved resin formulations that extended fuel storage time from 5 hours to 12 hours, allowing pre-mission preparation the night before and reducing ground crew workload during
critical pre-dawn hours.
The tanks also received better cold weather treatment, preventing fuel line freezing at high altitudes.
The D-Day invasion on June 6, 1944, showcased the complete transformation that drop tanks had enabled. Fighter bombers with paper drop tanks ranged far inland, disrupting German reinforcements hundreds of miles from the beaches. Captain Robert Johnson of
the 56th Fighter Group flew 3 missions on D-Day, each time with paper drop tanks, allowing him to loiter over the battlefield for extended periods. The ability to provide continuous fighter cover over the invasion beaches
and deep into France proved crucial to the success of Operation Overlord. Production statistics from mid-1944 show the scale of the operation. British factories were producing thousands of paper drop tanks monthly, with Bowater Lloyd as the primary manufacturer, supplemented by other facilities. The entire Allied fighter force in Northern Europe could be equipped with fresh tanks for every mission. Metal tank production, by comparison, remained
limited by aluminum availability and required critical resources needed for aircraft production.
Colonel Francis
Gabreski, leading ace of the European theater with 28 victories, flew his most
successful mission on July 5, 1944, using paper drop tanks. Leading the 61st Fighter Squadron to Magnaberg, he shot down 3 Messerschmitt Bf-109s after dropping his tanks near Brandenburg. His after-action report noted perfect
tank performance at 30,000 feet despite -40-degree temperatures, clean release when bounced by enemy fighters, and critical improvement in climb rate after release.
By September 1944, the Luftwaffe fighter force was effectively broken. General Galland reported to Hitler that American fighters were ranging over all of Germany with impunity. The long-range escort had not only protected bombers, but had engaged in systematic destruction of the Luftwaffe through aggressive fighter sweeps. German pilot training programs forced to operate from scattered fields to avoid attack produced pilots with fewer than 50 hours of flight time compared to 400 hours for American pilots. First Lieutenant Urban Drew of the 361 Fighter Group achieved a remarkable feat on October 7, 1944. Flying with 2 108 paper tanks, he escorted bombers to Poland near the Polish border, a round trip of 1,400 m. After dropping his tanks, he shot down 2 Me-62 jets, becoming one of the first pilots to down the revolutionary German fighters. The efficiency of paper tank logistics became crucial during the Battle of the Bulge in December 1944. With forward airfields hastily constructed and supply lines strained, the lightweight compact paper tanks could be delivered by light aircraft or even parachute drop. Captain Jack Ilfrey, commanding the 20th Fighter Group, documented surge operations
during the Bulge, noting they flew 3 missions on December 23, each time with fresh paper tanks with ground crews able to rearm and refuel, including
mounting new tanks in 20 minutes. German technical intelligence officer Major Wilhelm Hoffmann, captured in April 1945, provided post-war testimony about the impact of Allied drop tanks to U.S. interrogators. He stated that they tracked every innovation in Allied fighter capability, and the appearance of paper drop tanks was more strategically significant than any new aircraft type. It meant nowhere in the Reich was safe from fighter attack. Their entire air defense strategy based on concentric rings of fighter bases became obsolete overnight.
The numbers from the Strategic Bombing Survey were conclusive.
In 1943, before
widespread use of long-range escort, German fighter production had actually increased despite bombing.
By late 1944, with Mustangs ranging over every German factory, fighter production dropped 40%. More critically, fuel production fell 90%, grounding even the fighters that were built. Lieutenant Colonel John
Landers, commanding officer of the 78th Fighter Group, flew 103 combat missions,
many with paper drop tanks.
His assessment provided to Air Force historians in 1962 emphasized that the
paper drop tank was the unsung hero of the air war, simple, cheap, and absolutely essential. Without those British paper tanks, escort to Berlin would have been impossible,
and without that capability, the Luftwaffe could not have been broken.
The production techniques developed for paper drop tanks influenced post-war manufacturing in unexpected ways. The lamination process was adapted for civilian aircraft components and eventually aerospace applications. The quality control procedures established at Bowater Lloyd became standard in British manufacturing.
Workers trained in precision paper construction founded companies producing everything from aircraft interior panels
to architectural components. Major Richard Turner of the 356th
Fighter Group provided a combat pilot's perspective in his 1946 memoir, calling the paper tanks their passports to Berlin that looked ridiculous but worked
perfectly.
He flew 89 missions with paper drop tanks without a single failure.
Soviet observers attached to 8 Air Force units reported back to Moscow about the paper tank innovation.
Colonel Ivan Kajub, the Soviet Union's top ace, tested captured German drop
tanks and compared them to American paper tanks in 1945. His report noted the American tanks were
superior in every measure through brilliant simplicity, not advanced technology. The production surge for the final offensive into Germany demonstrated Allied industrial might.
Every fighter mission over Germany employed fresh tanks. Ground crews at forward bases in Belgium and Holland could equip entire fighter groups in hours rather than days. Lieutenant Robert Powell of the 55th Fighter Group experienced the ultimate test of paper tank reliability on March 24, 1945 during Operation Varsity, the Rhine crossing. Taking off at 0600 with two 108-gallon paper tanks, he flew to the Rhine. Drop tanks when engaged by Mi-262s near Frankfurt, fought for 15 minutes.
Landed at a forward strip, took on new tanks, and flew another mission, demonstrating the system's flexibility
and reliability. The last major employment of paper drop tanks in the European theater came on
April 25, 1945, when Mustangs escorted reconnaissance aircraft to Hitler's
mountain retreat at Berchtesgaden, a round trip of 1,400 m. The mission demonstrated total Allied air dominance with fighters ranging over the furthest corners of the Reich unopposed. Colonel
Benjamin Davis Jr., commander of the 332nd Fighter Group, the famous Tuskegee
Airmen employed paper drop tanks on escort missions from Italy into southern Germany. His after-action report from
March 31, 1945 stated that the 108 tanks allowed them to escort bombers to Munich and engage enemy fighters throughout the mission with perfect performance at altitudes exceeding 30,000 feet. These simple paper tanks gave them the range to prove their worth as fighter pilots. The psychological impact on German civilian morale was documented in captured
letters and diaries. Citizens wrote about American fighters overhead constantly dropping fuel tanks made of
paper in parks and streets, demonstrating such wealth that they could carry fuel in paper containers and throw them away. Post-war analysis by the Pentagon revealed the strategic importance of the paper drop tank program.
The savings in aluminum alone justified the entire program.
The reduced shipping costs,
simplified logistics, and decreased ground crew requirements multiplied the benefits. Most importantly, the extended fighter range saved an estimated 8,000 bomber crew lives by reducing loss rates from the catastrophic levels of late 1943 to sustainable levels by early 1944.
Air Chief Marshal Arthur Harris, commander of RAF Bomber Command, initially skeptical of daylight bombing, acknowledged in his memoirs that the American achievement in extending fighter range through disposable tanks validated their entire strategic concept.
General James Doolittle, commander of
the 8th Air Force, provided the strategic assessment in his final report. The extension of fighter range through auxiliary fuel tanks, particularly the British-manufactured paper tanks, was the single most
important tactical development of the air war in Europe.
It transformed the P-51 from a good fighter into a
war-winning weapon system. The ability to escort bombers to any target within Germany shattered the backbone of the Luftwaffe and secured Allied air dominance essential to victory.
The human side of the paper tank story extended to the thousands of workers who produced them. At the Sittingbourne facility, manufacturing crews, 70% of them women, operated around the clock in 3 shifts to meet demand. They understood that every tank they assembled allowed Allied aircrews to fly farther and return home more safely. The technical performance achieved was extraordinary for such deceptively simple devices. Each 108-gallon tank could endure 3 g of acceleration when full and 9 g when empty. They operated flawlessly across extreme ranges of temperature and altitude.
Fuel transfer rates matched internal tank systems, allowing seamless transitions during combat.
All of this was accomplished using compressed paper and plastic resin, materials available to any industrial nation, but combined through uniquely Anglo-American innovation and manufacturing capacity. German aircraft designer Willy Messerschmitt, interrogated after the war, acknowledged that they were aware of auxiliary fuel tanks and employed them, but never envisioned the mass production of disposable tanks made from non-strategic materials. The Americans and British transformed a logistical challenge into a production advantage. The effect on military doctrine was deep and enduring. The United States Air Force adopted long-range fighter escort as a foundational principle, shaping aircraft design throughout the Cold War and beyond. The idea of disposable components to extend capability became standard practice, from fuel tanks to sensor pods to weapons pylons. The paper tank demonstrated that innovation did not require exotic materials or revolutionary technology, only creative use of existing resources. Lieutenant General William Kepner, commander of the 8th Fighter Command, summarized the impact in testimony before Congress in 1946. The paper drop tank gave U.S. air superiority over Europe. Without it, our bombers would have continued to suffer intolerable losses. Without it, our fighters could not have hunted the Luftwaffe to destruction.
Without it, D-Day might have failed. The environmental legacy was notable, though largely unrecognized at the time.
Approximately 15,000 paper tanks dropped over Europe during the war biodegrade within months, unlike metal tanks that became permanent hazards.
French agricultural reports from 1946 indicated no lasting soil contamination from paper tanks. Areas littered with metal tanks, by contrast, required extensive cleanup lasting into the 1950s.
Meanwhile, quality control innovations developed for paper tank production influenced manufacturing standards worldwide. The demand for absolute reliability in a disposable product drove advances in statistical process control later adopted across multiple industries.
The notion that simple, good enough solutions could outperform over-engineered alternatives reduced costs while preserving dependability. The strategic implications extended well beyond World War II.
During the Berlin airlift of 1948, transport aircraft used disposable tanks derived from wartime paper tank technology to increase range. Improved versions appeared again during the Korean War, flown by F-51 Mustangs operating from Japan. While the technology evolved into modern composite materials, the fundamental concept of lightweight, disposable range extension remained unchanged. The final combat use of paper drop tanks in World War II occurred on May 7, 1945, one day before VE Day, when Mustangs of the 357th Fighter Group flew a last patrol over Czechoslovakia. Lieutenant Robert Foy, on his 89th mission, recorded carrying 2 108-gallon paper tanks to Prague and back, releasing them over a farmer's field near Pilsen. At veterans' reunions over the decades, crew chiefs and pilots shared stories of the paper tanks. At the 50th anniversary gathering at Duxford in 1995, former Luftwaffe General Adolf Galland met American fighter pilots. When asked about the turning point of the air war, Galland gestured toward a displayed paper tank, calling it the simple device that meant they could never be safe, never rest, never rebuild.
It brought the air war to their doorstep every day until nothing remained to fly.
The apparent simplicity concealed a sophisticated understanding of materials science, aerodynamics, and production engineering. Each tank embodied thousands of decisions about materials, construction, testing, and quality assurance. Success came from making all those decisions correctly and then executing them on an unprecedented scale. Captain Louis Cords of the 3rd Air Commando Group, who flew Mustangs in both the European and Pacific theaters, compared their effectiveness across environments, noting that the same simple solution worked in Pacific humidity as well as European cold, evidence of sound engineering that transcended theater-specific demands. The legacy persisted in unexpected ways.
Phenolic resin technology developed for tank construction became the foundation for early circuit boards in the electronics revolution. Lamination presses designed for tank production were later adapted to manufacture television cabinets in the 1950s.
Workers trained in precision paper fabrication went on to establish companies producing everything from aircraft interior panels to architectural materials. Wing Commander Peter Brothers, an RAF fighter leader, observed American operations with paper drop tanks and remarked that Americans approached war like a business problem, purchasing range by the gallon in disposable containers, with no romance or elegance, only relentless efficiency. The British supplied the idea, the Americans supplied mass production. Together they gave the bombers safe passage to Berlin. The final accounting appeared in the United States Strategic Bombing Survey Summary Report, which documented that the development and deployment of auxiliary fuel tanks, particularly the 108-gallon laminated paper tanks, extended fighter escort range from 475 miles to 850 miles. This 79% increase placed every target in Germany within escort range. The resulting reduction in bomber losses saved an estimated 8,000 aircrew lives and enabled the strategic bombing campaign to accomplish its objectives. The story of the paper drop tank reveals a fundamental truth about modern warfare. Victory often depends not on revolutionary technology, but on innovative application of simple solutions at massive scale. British Paper Company, American fighter aircraft, and compressed papers saturated with plastic resin combined to defeat the Luftwaffe and secure Allied air dominance. Roughly 15,000 paper drop tanks, dismissed as impractical by experts, proved decisive in achieving air superiority over Germany. Each tank that performed as intended represented a life saved, a mission completed, and a step closer to victory.
Bombers could finally reach their targets with protection. Fighters could finally fight where the enemy lived.
And the air war was won not by superior aircraft alone, but by superior range, provided by disposable paper tanks that looked like little more than oversized cardboard tubes, yet carried within them the fuel for victory. The innovation arose from necessity, when metal was scarce and bombers were being lost. British ingenuity met American industrial capacity to produce a solution so straightforward it seemed improbable. Paper and resin, newspaper companies, and fighter aircraft converged to solve one of the war's most critical problems. When Lieutenant William Overy flew over Berlin on March 4, 1944, with paper tanks beneath his wings, he carried the culmination of months of development, testing, and production by thousands of workers who would never see combat, yet whose contribution proved as vital as any battlefield triumph. The paper drop tank stands as a testament to the power of practical innovation over complex engineering, demonstrating that sometimes the best solution is not the most advanced, but the most achievable at scale when it matters most.